Welding equipment. So we started welding with oxyacetylene, which is using two separate types of gases that when we combine them, we create that intense heat, which we can then melt metal with, right? The benefit of oxyacetylene is that it's normally cheaper, dealing with, you don't have to use power. We could bring that portable around. The gases aren't that super expensive. It's not that difficult to get started. And we could cut with that, we could heat with that, and then we could also weld with it. So we could have the benefit of owning that oxygen acetylene type setup. We went the next step further, which is electric arc welding or stick welding, which is utilizing a stinger or electrode, which we are then arcing against our base metal. So we're using high amperage or high voltage current that's going to melt our stick electrode and our base metal together. So we have that filler rod always at that point. Another benefit is that we're utilizing a flux-coated rod, which is going to shield our weld so it does not, I guess, come in contact with the air and rust prematurely or get porosity in it, which are small, very tiny holes, which will compromise that weld. Right, stick welding is also great due to the fact that we can weld dirty metal. We can kind of push through grease. We can weld different types of metals. And we're going to be utilizing sticks, which are consumable, but it's a good alternative to, again, getting something back in production again. Our third method, which we lectured on earlier, is going to be MIG welding. So metal inert gas welding. So this is going to use a wire type feed system. So we talked about our gun, which has that nozzle, and then our wire, which feeds out through our contact tip, which would be right in the center. So if we pull this nozzle apart, again, we have our cone here, which is going to distribute the gas through that, kind of get it to swirl and go onto our weld. Our contact wire, which is kind of hard to show up because the camera refuses to focus, but that's all right. Finally, our contact tip, which is replaceable. This will just simply unscrew, and then we kind of look through here and we can kind of see the gas ports from where the gas or our shielding gas is dispensed. So it's going to be on a long type cable, which is going to feed the wire through. So on the front of the machine, we're going to have two dials and then our on-off button. So the on-off button is simply going to turn the machine on or off. And then we have our voltage on the bottom, which is represented in numbers. So we have here again number 1, 2, 3, and 4, and that's going to represent and go along with our chart. On top, we have our wire feed speed, which goes all the way from basically not all the way to 100. So depending on where we're setting our voltage to where we set our wire speed is where we're going to be welding. So this is a smaller welder. It's a 110 version welder, so it doesn't have as much oomph, so we can't really weld as thick of steel with it. But it's a good entry-level welder that will put things back together again or fabricate new things. So if you're looking for an inexpensive machine for your shop, this will be definitely a good starting point. On the back, we do have gas, and our gas is not to create heat or to fuse current. Our gas is there to shield that weld. So instead of having a flux core weld or even a flux rod like on stick welding, we have our shielding gas, which is an argon CO2 mixture. If I get this to, let's see if we can kind of get this to zoom around. All right, so we have a handle at the top. Now we're going to go into the inside of the machine. As I kind of take you guys in, so we have our spool of wire here, which is where we're going to be actually melting and creating that to fill in our metal. We have our wire feeder here, and then our adjustment. So this is going to be how much tension we put onto our wire. And again, depending on different wire, it's going to kind of say it on our wire spool of what tension we need to have. Also, we could have the option of switching polarity up here as well. So we could be that DC positive or DC negative, depending on how we're setting this up and what we're actually welding. Kind of going up here, this is our chart. So our chart's going to tell us, again, we're going to decide on what material we're welding, what our wire type is, and then the suggested shielding gas for what we're actually welding in that. So what I have in here is solid steel wire. I'm at 0.030. I'm going to have my 75-25 gas or argon and CO2 mixture, and I'm also welding with solid wire, so solid 0.030 wire. So I can't weld, or I'm not supposed to weld, anything that is 24 gauge. However, I can weld a 20 gauge or an 18 gauge or even all the way up to 11 gauge steel, depending on these settings. So if I'm welding 11 gauge steel, I'll go to my 0.30 wire and I see a number 440. So going to the front of our machine to weld that or get a good starting point, we would bring this to 4, which would be our voltage, and then our wire speed, we would want to go to 40. And that would get us pretty darn close with the correct settings to begin our weld. And remember, we're going to listen for that specific sound. So we want to have that bacon egg frying sound, or not bacon and eggs, but just an egg frying sound. That way we would know that we're pretty close. And as we watch that metal flow into our weld and how it welds, how the wire feeds out, you're going to get a feel, and we could adjust those settings to make sure that we are welding properly.